Okay, we're starting chapter 8, which deals with hypothesis testing, and this is just the basics that's here. And a hypothesis in statistics. Hypothesis is a claim or a statement about the property of a population. Hypothesis test is a procedure for testing a claim about that. There's lots and lots of detail in the PowerPoints. This is the outputs, and this is the way it looks in StatCrunch. There's a lot of important information in these PowerPoints. The null hypothesis is a statement that the value of the population parameter, some claim, and then the alternative hypothesis. Your null hypothesis is generally differs from, the alternative is going to differ from the null. The null, generally speaking, is the equals, and the alternative hypothesis, it uses one of these three symbols. And then here's a procedure for hypothesis testing. Confidence intervals, you've already talked about. Use the claim to create the null hypothesis. There's the steps that are involved. Read through those. There's about 5 steps that are involved. It's a good idea just to read through this. We could talk about critical regions. When you're dealing with hypothesis testing, you have two-tailed when it's not equal to, left tail when you're dealing with less than, right tail when you're dealing with greater than. There's a p-value method, that the probability of getting a value of a test statistic that is at least as extreme as the test statistic obtained. Finding p-values, this shows you how to find p-values. What type of test is it, left, right, and so forth from there. And with the p-values, you go through, you see where your critical areas are. There's a caution, don't confuse all these p's. There's a lot of p's involved. And then there's a critical value method. You see right here the critical value. If what your critical value is here, if you run your test and it falls in here, it is in the reject region, so to speak. Then you make a decision. If p is less than or equal to alpha, you reject. If it's greater than alpha, you fail to reject. You're still at step 8, wording your final conclusion. It tells you what to do here. This is an important little chart. And then, of course, you go on into confidence intervals and type 1, type 2 errors. I know I've just kind of skimmed through these, but I just wanted you to be aware of what's here, and you can come back to them when you need to. Okay, let's look at this little problem. The Erickson method is one of several methods claimed to increase the likelihood of a baby girl. In a clinical trial, results could be analyzed with a formal hypothesis test, with the alternative hypothesis being p is greater than 0.5, which corresponds to the claim that the method increases the likelihood of having a girl, so that the proportion of girls is greater than 0.5. If you have an interest in establishing the success of this method, which of the following p-values would you prefer? Now, keep in mind that this is the p-value that you want it to be less than or equal to alpha. So the smaller it is, the better it is. So which of these is the smallest number? That 0.001 is preferred because it corresponds to the sample evidence that most strongly supports the alternative hypothesis that the method is effective. Okay,